Jai Hind students, welcome back to my Python tutorials. And today I'm going to talk about the 7 chapters of your computer science with Python. And the chapter name is Idea of Algorithmic Efficiency, Chapter 7 Python. Basically in this chapter we'll talk what algorithm is and how to measure the efficiency of the algorithm that we write for a particular program. So certain objectives are there as I have jotted down. You have introduction, then the internal factors and the external factors that affect the algorithm, performance or efficiency, then the complexities or in computational, and then estimating complexity of algorithm, big O notation, dominant term, and guideline for computing complexities. There are again different guidelines that we'll see, and the calculating the complexity. There are some factors on which we basically calculate the algorithm complexity. Now before saying anything about this, let's see why we write algorithm. Algorithm, as you all know, it's a method or a procedure that you write to write a program, and that easily again digestible to everyone. So if I want to again develop a program, I have to first sit down and I have to write how this program will work. In the normal statement, general statement, or in English, so that anyone who will again write further can go through that algorithm and write accordingly the language that you'll use. For example, in Python, if I'm writing a program, if I know Python, I can only write it, but algorithm can be understood by or understand by everyone who will see it. Either he or she is a programmer or is not a programmer, hardly make the difference. So what is algorithm? Basically it's a pseudocode or a false code or a method or a procedure or a set of steps of how the program will flow. And then the programmer basically again write the program according to a particular programming language, the kind of algorithm it was. Understanding of algorithm is very required by every programmer or every individual, because it helps us to understand how the program will work, how the program will flow. That is what algorithm is. So what is algorithm? Is a pseudocode or is a false code or a general statement that you write how a program will work, or simply it's a method or procedure to perform a task, that basically the task that you want to do with the help of computer program. That is what algorithm is. And we are going to talk about algorithmic efficiency, means how the efficiency of an algorithm will be measured. So the chapter basically will talk about it. Now, there are 2 factors always in every algorithm that we write. One is the internal, one is the external factor. Now, external factor that depends on many things and can be controlled easily. But the internal factors are very crucial for any kind of algorithm or to check the complexity or efficiency of an algorithm. Now, in case of internal factors, we have 2 major factors that considered to be factors as an internal. One is a time and one is a space. It means how much time algorithm will take to execute a set of a statement, and a space is how much memory it will utilize of your computer. And as you can understand, these 2 things is very crucial for any program to execute. How much time it is taking to execute it, and how much space are required in our computer. These 2 are very crucial factor to measure the efficiency or complexity of a computational algorithm. So that's why time and space, these 2 are very crucial. And external agencies, maybe the OS that you use, the types of computer that you use, the speed of your computer, and likewise we have size of the inputs of the algorithm that also considered to be as an external factors. So 2 things must be very clear. There are 2 factors that definitely again make the difference to measure the efficiency of an algorithm. One is the internal, one is external. And as I mentioned, in internal we have 2 things, time and space. Keep that in mind, because people may ask you what are the 2 factors which considered to be an internal factor for algorithm complexity. So you must say time and space. Once we are talking about the time span which is required to execute a particular algorithm is called time, and a space is a RAM part or memory utilization of your computer. How much less memory algorithm is utilizing, that much better it is, and how much less time algorithm takes to execute the statement that you have written is considered to be the one of the best one. And as I mentioned, the external factors can be controlled easily. That's why we are not talking much about the external factors. Now, computational complexity. This is one of the term, computational complexity. Try to understand these two terms. Computational, or simply you can say computational complexity. Computational word means utilizing a computer to solve a problem. It means technique that you are using of a computer to solve a problem, that's a computational. And complexity is how cumbersome it is, how easy it is, that's called computational complexity. Second word for the computational complexity it is a efficiency of your computer or efficiency of an algorithm. So you can say computational complexity is the efficiency of an algorithm that basically talked how nicely algorithm works, how less time algorithm takes, how less space algorithm used to execute a particular code, and that is what the computational complexities. So this efficiency of any algorithm is considered to be the computational complexity. Now, estimating the complexities of an algorithm, that I already again said, estimating of the complexity of algorithm always depends on the two factor, that is the internal factor, the time, how much it takes to execute a set of a statement with a set of input, and also the space that it relies to execute it. That two factors basically estimate the complexity of the algorithm, how much less time and how much less memory utilization the algorithm have. That basically talked about the how complex or how easier it is. Now there is a notation that's called big O notations in Python to measure the complexity, to measure the efficiency of any algorithm. So we'll talk about the big O notation. Big O notation is basically a notation or is a method or a technique to measure the complexity of any algorithm, and that depend on many factors. For example, suppose O is since it is a big O, that's why the size of the O you have to write bigger, O(n). Now n is the size of a particular algorithm, you can say, and you have a O(n) square. Now these two things I'm again denoting O(n) or O(n) square, or you may say simply O(n) square, or here it is a 2 to the power n, 2 to the power n. Now this is what the notation, big O notation for two different kind of algorithm we have. Suppose if there is a size 10, 20, 40, and likewise this is the input in the sense of number of line, 10 line, 20 line, 40 line. In case of n square, it will take the 100, because 10 square, and 2 to the power n means 2 to the power 10. As you can understand, n is here 10, again 20 means it's a 400, and here it is a 2 to the power 20, and again it is a 1600 maximum, and here it will be 2 to the power 40. As you can understand, it means this is considered to be the more complex than the n square. So algorithm which big O notation is n square considered to be more efficient than the 2 to the power n, because it will take much time to execute a particular set of input. This is what the big O notation is. Big O notation method is basically a notation method to measure the complexities of any algorithm here, and you can measure as a time, and there is a set of input constantly we are providing for a particular algorithm. If the n square is a maximum or optimum, again complexity of that, as you can understand, this is 100 and this will take the 2 to the power 10 time. That's a too much again time it will take, and that's why 2 to the power n big O notation considered to be the less efficient than the n square algorithm. This is what the big O notation is. Now dominant term, to understand the dominant term, if there is a n square plus bn plus c, for an example its expression or is a big O notation. As you can see, the n square is the biggest again expression in this. Here it is and it is this. So we'll only consider the O n square, not the or rest other expression we will ignore, and where the a, b, c is a constant. So at a constant value of ABC, in this expression a n square plus bn plus c, n square will be considered as a factor for measuring the efficiency of the algorithm. Rest other are lesser than that. That's why we'll ignore this. This will be the factor which will make which will let us know how cumbersome, how efficient, how complex an algorithm is. This is how dominant term, here n square is a dominant term than the bn, because as you can understand, because it will be just double. Now guideline for computing complexities. Now there are certain guidelines that always again help us to know the complexity of an algorithm. Now one is, you always have factors that you want to measure. So find out the factor that you want to determine, or find out the factors that you want to evaluate. And two major factors, as you all know, time and space is the factor that you have to measure. This is the first again guideline. Always have the points on the basis of that you want to check the complexity of the algorithm, and here it is a time and space. Second is the size of input. Size of input is also the factor. Once you have decided 500 lines, 1000 lines, size of input, then to process that, how much time and how much space the computer will take. So second is the size of input, and third is, of course, you have to check the performance of it. Under three different circumstances you have to check the performance. One is the best performance once an algorithm gives. Second is the worst again performance an algorithm is giving with the same set of input and the time, and third is the middle. And you have to compare all three again factors. Once it is giving you the best performance, once it is the worst case, and third is the middle case. These are the guidelines to again check the complexity of an algorithm. What are these? First is the factor that you want to check, that is the time and space as in crucial or internal again factors. Then the second is the size of algorithm, that also you have to decide, and third is a three case you have to check with that size when it is performing best or giving you the best performance, and when it is giving the worst, that may be the scene once I am checking a particular again task or performing a particular task in the programming. Sometimes it takes less time, sometimes it takes the more time. So worst and best, and then third one is a middle, that is average one, and these three cases should be checked. Now come to the calculating the complexities. Now on what basis and what are the things we should again check or calculate for the complexities of an algorithm? Now in our program we may have a loop, we may have a nested loop, we may have a if then else. These are the three factors, as you can see, loop, nested loop, and then we must have a consecutive statement, the statement that continuously again execute. That's a consecutive statements. If then else I've already talked, and last is a logarithmic and complexity. This is the last one. Now looping, as you can understand, the set of statement in a particular loop that will iterate a particular set of time, definitely the complexity of algorithm depend on it. Now let's see how the looping complexities can be measured. Now for an example, I'm using a loop for I in range, and here n I'm putting as in range, and then inside it there is some statement. Simply you may have any set of statement. Now suppose a time you just said x equal to x plus 2. Now to execute this, suppose the time it takes the c, the constant time that it will take to execute this statement within the loop is c. It means it will execute n time. Time is n. It means the big O notation, if you'll see, to c star n, that is cn. It means in the big O again notation will write on. I hope you must be getting. In a particular loop that will execute n times, and if the time it will take to execute this is how many time it will execute, 5 or 6 or 7, and here there is a statement that is in the body, it takes to execute a single time execution of this statement c. So then total number of time it will execute n time. It means total complexity will be c star n, that is cn. As you know, c is again the constant, that's why n is a notation, so you can represent the on. This is how we can present a loop. Now if it is a nested loop, suppose, now same thing if I'm writing by the nested loop for I in range inside the bracket n, and then you are using for j in range, and then n, and inside it if you are saying x equal to x plus 2. Now this is a statement. Now just see, this is n time outer loop, and the inner loop is also n time. So this statement will iterate the n squared time, and if the c is a time it will take as in constant time, then c star n square, that is cn square, that is in presentation you can say n square is the complexity of this. So as you can understand, in the single loop it was only n, and n square of course will be more again complex than the n, and this is how loop and nested loop case me you can check the complexity of any again algorithm. N time, it means this statement will execute due to this n time, and upper loop is n time, the overall it is n squared time, and if this statement will take the c as a time to execute a single time, the total execution time will be c star n multiply n square, cn square, and in the big O notation you can present it as a c is a constant, O big O notation n square. N square is a representation of that. And likewise the every statement, suppose x equal to x plus 1, and then you are saying z equal to x plus 5, if it is a c0 time, if it is a c1 time, there's all different times we have to add because it's a consecutive statement. So all the statement which execute consecutively or one after other, if this is a c0 and this is c1, total time if you want the c0 plus c1, this will be the total time it will take to execute the consecutive statement of it. Then come to the if then else. As you all know, if is a condition, and inside the if it is a true, then certain thing you want to, otherwise you'll go to the else. Now for every if, now just see, if x greater than y, then you are saying return x, else then we have something for I in range, and then some certain task you have. Now try to understand this situation. This again, if x greater than n, this statement is there. So maybe C0 you can assume. If it is a C0, then it is a C1 because it's a return act. This will be again a statement. If this statement is right, then it will jump to this. So this is 2. Now else is again separate segment, and for this it is n time, and there are statements, suppose C3 and C4. Try to understand this, how the complexity of this will be measured. So we can say C0 plus C1 and then plus, here it is C3 plus C4 because that will work together, and star n time because it is in the loop. So overall complexity, as you can understand, is a n. Here also is a simply n is a factor, so O notation is a n. Got it? So for every again consecutive statement, it will take a time. For example, this is a C0 and this is C1. If this will occur, then second statement also about 2. That's why the total time will be again C0 plus C1. But if this is not there, then it will come to this. Then these two statements will execute together. That's why I kept in the bracket C3 plus C4 star n, because n time it will execute. The total duration will be whatever the C3 plus C4 star n. And that is how you can measure the if then else. And then the logarithm complexity. Now logarithm complexities, that basically again works once we have a binary search. Once we are searching a particular again array, then we use these techniques to measure the complexity of it. So overall, what we have seen, what algorithm is. Algorithm is a method or a procedure that help us to write a program. Set of steps that we write in a normal language to convey, to again represent a program is called algorithm, and the algorithm complexities we will measure on the basis of some factors, internal and external. In case of internal factor, there are two things, time and space, how much time it takes to execute the set of statement and how much memory it utilizes of our computer. And then external agencies, in which environment we are working, the kind of OS we have, Windows and other. And then the number of lines is also the factor. The speed of our computer is also the factor. But these are the external agency can be controlled. That's why I hardly make the difference. And then we have learned big O notation is one of the again presentation or notation method in Python to measure the complexity or efficiency of an algorithm. And there are certain guidelines. The dominant term, as I mentioned, whenever the power of n is bigger than the other, then maximum power you can present, and that's what it's called a dominant term. And guidelines, as I mentioned, there are 3 guidelines we have. First, you have to take the point on basis of that you want to measure it, that is time and space. Second is again the size of input is also the factor. And third is the performance on 3 different cases, worst case and best cases and the middle case or average case, that you have to find out. And then in a program, how many loops are there, how many nested loops are there, how many consecutive statements are there, and if then else, or logarithm complexity. This all 5 points is a calculating complexities factor for any algorithm. So with this, I am able to finish this chapter, that is idea of algorithmic efficiency, chapter 7 of yours. If you have any doubts, feel free to ask me either with the video comments or WhatsApp message. But in this chapter, people may ask you what algorithm is, then what are the factors to measure the complexity of an algorithm, then what do you mean by big O notation and how big O notation works. So maybe 1 or 2 marks question generally comes from this chapter in class 12. But go through this small chapter and I hope easily you can digest. Kindly subscribe the video so that the next video's arrival you will come to know easily, and have a note of this chapter and let me know if there is any difficulties. Thank you all.